I'm Roberto Cortez. I'm from Portugal. This is my first time in Russia, so I'm very happy to be here. You have a wonderful country and a wonderful city here in St. Petersburg that I have the occasion to visit yesterday. I've been working a lot with the enterprise stuff over the last couple of years. Right now, I'm working into a company called Talkdesk. Maybe you haven't heard about that before. We're actually one of the lead cloud providers for contact center software. So if you have any issues on that, you can try to reach me out. And some of the things I'm going to show you are a couple of things that I've been working on at Talkdesk for handing out some of our products and some of our businesses. So here are my contacts, so feel free to use them if you want to reach me out. Either on the session you can tweet about stuff, or you can reach me out later. So feel free to use them anytime you like. Okay, so our agenda for today is we're going to talk a little bit about microservices, about what GraalVM is. I'm going to have a look on a little bit of things about MicroProfile, and of course I'm going to show a lot of demos about all of these. So without further delay, microservice anyone? Who's here using microservices? Yes. Who's here not using microservices? Okay, would you like to use them sometime? Really? Well, apparently some of these days you have to make some sessions about microservices to get accepted into conferences, so that's why I do. But I actually, well, you're in a safe environment, so if you don't like microservices, you can tell, right? Who here really likes microservices and do microservices? Really? Okay. Well, I personally don't really like them, but since that's the standard these days, I'm trying to find like some easier ways to help us develop those kind of services in our infrastructures at least. Okay. So let's skip that one. So when I usually ask about something, I go to Twitter and ask people questions. So when I ask people about what to think about microservices, these are the answers that I got, right? And architect's dream, developer nightmare. Right? I'm an architect now, so I usually push that to my teams, and they can all on the stuff. I can just bring that all up to me. One day, microservices share some links and will call servlets. Yes? Okay. So someone just hacked my slides. This is popping up every time. Anyway, so why do we end up doing microservices? So for people that are already doing it, but also for people not doing it. So some of the things that we usually look at is because we want to deliver new features quicker, right? So if instead you have your old monolith, which has like a big pile of code, and you want to develop new features, and then you have like these 2 or 3 month release cycles, right? We all been through that in the last few years, or even the last few decades. Then, oh, we need these things super quick, so, oh no, we're just gonna deliver to you in the next 3 months, right? You relate to that, yes? So, microservices kinda help you out to fix some of those issues. And then, of course, because you split those things into smaller features, then you can have smaller teams that are gonna handle all of that. So, one of the things that I have to realize is, when you're talking about microservice itself, is not only the technical portion of the architecture itself, but it's also a way of developing. So it's not only the technical stuff, but also team composition, how you organize yourself, right? So you're able to have teams that are just going to handle those microservices independently, right? Kind of like an external provider for those features that you want to develop. And for me, this is actually one of the main benefits for microservices is that you can scale your service independently, right? So it doesn't make any much sense when you have like a big monolith and you have, let's just say, a service is going to do a streaming of some sort, and you have something that's going to register users. They're going to use the same resources, right? Doesn't make any sense. So most likely you want to assign more resources or different kind of resources for the streaming service than the one that's going to create your users on your system. And of course, now everyone is deploying on cloud, and doing cloud deployments using this kind of architecture is way easier than just doing monolith. You can do it, but the expensive amount that you're going to get, you're going to have a couple of issues. Okay. But when you get this is what I like to call my personal microservices hell. And why? Well, one of the things that people talk about is, well, you have multiple services, you have multiple teams, so now teams are going to start picking each language they like to work, right? So now you have to start supporting multiple languages. Now people are going to start developing microservices in Java, Node, Python, R, Ruby, whatever. Do you guys relate to this? How many languages are you using in your microservices? Just one? Many? Many, yes. Java, JavaScript, Python, Ruby? Yes? Okay. And then, but when you start looking into those services, right, you start seeing that you have the same amount of, or you have to cover the same amount of features, right? So all the services require configuration, all the services require authentication, all the services require logging, all the services require whatever you're thinking about. And then when you have all these multiple languages, then you have to multiply all that complexity across all these languages, right? So if you're doing configuration, you're going to require a library to do configuration on Java, another to do configuration on JavaScript, another to do that on Python, another to do that on Ruby, and you get the idea. And this just doesn't scale because now you have to maintain all these libraries, or if there is like some external libraries that you can use, most likely they're not going to cover the same features. They might be very similar, but they're not going to behave in the same way, right? So these of course increase the complexity of developing your product, increase the complexity of debugging stuff. So because when you're doing a service, it's going to behave a little bit differently because you're using a different library and using a different language. So you have like increased research time when you're doing debugging, and you have research time when you have to develop a new kind of packages to implement. And you may need to rewrite your own libraries to do all of that, right? So let's just say you're providing a client API for some of your customers to use. Well, you write that in Java, but then they're using Node or JavaScript or Ruby or whatever. Now you have to write a library that allows to plug that into Ruby or JavaScript. Is that right? So that's a pain. So I started to look into some things, and we all know that our Indiana Jones found the Holy Grail in the Last Crusade movie, right? But we haven't found the Holy Grail for programming languages. Or maybe we did, but we don't know yet. So that's where GraalVM comes in. Okay, so who here heard about GraalVM before? Okay, most of you, wonderful. Who's here using GraalVM in production? A couple of people. Wonderful, me included. So, well, let's see if I show you a couple of things, so you can now start using GraalVM in production with the things I'm going to show you. So, for people using GraalVM in production, wonderful, guys. You guys are pioneers. So, congratulations to you. Okay, so most of you guys already know about GraalVM, so I'm not gonna go very quickly for those slides. So, GraalVM is an open source project coming from Oracle Labs. And the idea is that you can have an universal virtual machine that you can run JavaScript, Ruby, Python, R, and of course all the Java JVM-based languages. So a lot of people are being excited about GraalVM because of native image compilation and about performance. But I think that one of the overshadowing features that GraalVM has is about all the polyglot context that not many people are talking about. So I'm trying to cover that gap and show a couple of crazy things here on some of my demos. Okay, so this is the overall GraalVM architecture. So the way that things work, and if you don't know about how the polyglot context works, is so all this started with when the JEP 243 came out, where it allows you to plug in your own compiler interface into the hotspot. So that's how GraalVM was born. So it only started first as a JIT compiler, but then the project scope expanded, and they started to build a couple of other things. So Truffle was already out for a while, and then just plug Truffle on the Graal compiler, which allow you to translate other syntax languages to the abstract tree used by Truffle that you can plug into the Graal compiler, and then able to run any other language like you will run plain Java, Kotlin, or Scala. So in the sense, what you have is a VM that's able to interpret all these languages together, running on a single instance of a VM, with all the implications that you have and all the cool things that you might get. And so what do we get with that? Let's have a look. So I'm going to do just the first, I'm going to show you just a couple of demos. If you haven't run GraalVM before, so it's nothing out of particular difficult. So let me show you here a very small example. So what I have over here is, I have a number API. Let me, oops, that's not good, okay. And there you go. Are you guys able to see this properly? I can just increase these a little bit. Okay. So what you have over here, and we're just going to focus on the other stuff first, but we have over here is just a Spark application that's starting up an endpoint running on a configurable port, and it's going to just generate a random number. So nothing out of the ordinary. So this is a plain Java application. And what I have over here is, if you do a Java.version minus version, you see that I'm running with the GraalVM. So GraalVM in itself, it's just a regular VM that you just install and use it as any other hotspot or J9 or whatever other VM you're using. So you're doing the exact same thing. So you'll use Maven. So I'm using Maven here to build this project. So let me, don't need install. So I can just do mvn package. Well, it's just a small project, so it's going to be super fast. Doesn't really matter. And now I'll just run it as any other application. So number API dot jar. There you go. So now it's running on 3.0.0.1. So this is running already with GraalVM, so nothing out of the ordinary. If I curl that one, and I'll call numbers API generate, yeah, I get my number. So really, really simple, right? So this is just running a plain Java app with GraalVM. So basically what you actually can do is, and because GraalVM already has a lot of performance improvements on the compiler, you can grab up your own application and start running it on GraalVM out of the box, as long as you're just on Java 8. So for now, GraalVM doesn't support other versions other than Java 8, but they're actually releasing a version that's going to support Java 11 by the end of the year. But that's just to have an idea. So if you want, you can use this particular tool, which is super interesting, SDKman. It's all used to manage multiple VM versions. So it's really convenient, because when you want to switch from one VM to another one, so that's one tip that I gave to you. And so why I started looking to GraalVM and why I think GraalVM might be useful. So for me, it's about interoperability between languages. So you could, and I'm going to show you how, if you just have a Java application and you can call JavaScript code, or you have a JavaScript application you can call Java code, or you have a Ruby application you can call Java code, and you get the idea. So now you have this environment where you can just call any other language from any other language, and you can, for instance, reuse libraries. So let's just say, if you think about the example that I gave you earlier, where you have a MicroProfile config, that's going to show you a bit later, and you want to do configuration of your applications, now you can use the same library for Java, Python, Ruby, R, whatever. And what you gain over there is you have the same consistent behavior across all the services, no matter the language you're using. How cool is that? Another thing is about shared tools, right? So since everything is running the same VM, now you can use all the debugging tools that you have available to your disposal. So for instance, Flight Recorder, VM Viewer, any other debugger, because since everything is running the same VM, you can actually debug all Java code, your Ruby code, your Python code, everything over there. So you don't have to like change from context to context and see what's happening on the other things. So you can run Java faster. So the GraalVM compiler is also way faster than the regular compiler, because it does a lot of other stuff. But the interesting thing as well over here is, because you're running everything on the same VM, when you interpret it into languages, you will basically do memory calls between, for instance, Java and JavaScript. So let me ask you something. Let's just say that you have a Java and a JavaScript application and you want to integrate both. What do you do? Sorry? Web service, you do a REST endpoint, right? Right, and then what do you get with REST endpoints and REST services? You get all these expensive serialization, deserialization, right? On the object, you get all the objects over the wire. So it's an expensive call. It's a very expensive call when you want to do that, just because you want to integrate those two services that don't able to talk with each other because they don't speak the same language. So you have to come to something agnostic. So that's why you use REST. But if you look into this, think about all the complexity and all the effort that's involved when you want to do all of this. Basically, maybe you just want to call a service because you have to integrate with that, and you have to do all this crazy amount of work just for integration. You're not doing business code. You just basically have to do REST endpoints, you have to do Open API, you have to do expose whatever, and that's not business code. It's just doing integration code, right? Well, in GraalVM, if you do it in this way, then what you can do is you just call whatever service you want directly, and you don't have any expensive calls on marshalling or marshalling object. You don't have the expense call of going through HTTP. Everything's in memory, and the things are way, way, way faster, right? Because everything's just done in memory. Another thing that GraalVM does is, when you're doing polyglot stuff, is the object memories that you have, actually, they are the same. So if you're doing a call between Java and JavaScript, the object and memory is the same. They just represent in different ways on both languages. But when you're passing references from one to another, it's going to be the same object. So there is no marshalling or copy values or whatever. So it's going to be super easy or super fast. OK. So let's look into some code, and I'm going to show you a couple of examples. So this is a way that you want to interpret Java with JavaScript, for instance. So in this particular case is I want to start the Java.io file into JavaScript. So what I do is they have an API that you can use. So you just do like java.type. You extract a file class. So that's going to reference the fully qualified name of Java.io file. And then you can call a constructor on that. So you can just do new file class. And if you remember, there is a string, one other constructor with a string that references a file name. And then you can call methods on that. You can just call file.exist. Or if you want to do a one-liner, you can also do that with like new Java type. You pass in the full qualified name again, and then the constructor arguments, and you're done. Or if you want to call a static method, you can just do java.type and then call the static method directly. Does that sound magic? Yes. Does this work? Well, I'm telling you that works, right? So that's going to work. I'm not going to show that Java file example, but I'm show a couple of others. Now, the secret over here is GraalVM, when you want to use interoperability, and you want, for instance, use JavaScript or Node or Ruby or Python, you actually have to use the ones that are given to you by GraalVM. So it's not that easy in the sense that, oh, let's use my own Ruby binary and that's it. But the point is, even the binaries that are given to you by GraalVM, they are pretty much the same native ones for Ruby, Python, GraalVM, or others. The idea here is GraalVM has to provide their own because they have to start a VM as well when they, for instance, want to run a JavaScript application. And then, of course, they have a couple of external arguments just to say, hey, I want to run this JavaScript version as a VM mode, so you can start the Java and the JavaScript context all together, so you can, of course, call both languages in the same VM. So, for instance, the idea over there, if you're setting a node, you say, I want to start node with a JVM option, and then you can pass in a class path. So in that particular way, you can load libraries into Node and interpolate them directly into JavaScript. Okay, so before going a sample, this looks very good, right? Of course, there are some limitations. So while the languages themselves are way easier to integrate because it's just syntax and most of the integration that's been done by the GraalVM teams are already working quite nicely to support the language features of JavaScript, Ruby, or Python and so on. That's one thing. The other thing is actually to support the ecosystem, right? Libraries that exist in those languages, and that's the most interesting thing. Now imagine that you have a VM where you have an ecosystem that's composed of all the libraries of all the languages in the world. How does that sound? Right? So that's some of the things that are trying to work right now, and I can tell you that, for instance, JavaScript, Ruby, and R, they are very well supported. A lot of the libraries that exist in the ecosystem are very, very supported on GraalVM. But if they're not, you can come to this page and you can look for the compatibility about a particular library if you use it. But I can tell you that most of the common libraries for JavaScript on Ruby or R, they're already very well supported and you can use them out of the box. So for instance, SQLite, you can use it very, very well. Okay, so let's show some things, a couple of other things over here. So a lot of other folks are really excited about the native image mode, and of course I also have a sample over here. I'm not gonna build it. These are the arguments that you use to build a native image. So there are a couple of frameworks that came out recently that kind of makes that easier for you. I'm here doing it manually, and I'm not going to build that because it takes a while, but I can show you. So I probably have here the output. So basically, it runs all of this, and what it does is it now generates a binary. So you have like 71 megs, so it seems to be quite big, but I'll tell you why later. So I'm going to do something that you should never do. So if I do cat number API, yeah, you never do this, but you guys believe that's a binary, right? So now you can run that as a plain binary, and you have my server running right over here. And if I curl that, well, that works. Great. Okay, so now I want to interpolate all of these with some Java libraries. And one of the things that I have some ideas is about using MicroProfile. So have you heard about MicroProfile before? Okay, a few. So it doesn't really matter. I'm going to show you a couple of things. And this is not, the things I'm going to show you are not just for MicroProfile, so you can pick your own library and use it, because probably it should work quite nicely. So what is MicroProfile? So MicroProfile is an initiative coming from the Eclipse Foundation that joined together a couple of companies and a couple of communities and also individuals. And they came with this concept called MicroProfile, which is microservices for Java. So if you, for instance, for Java EE developers, you know that the Java EE now called Jakarta EE has been dragging for some while, so there is not much innovation happening in that space. So we really require an initiative that allows developers to build microservices into Java, because there was nothing really standard. So there are other libraries like Spring and Micronaut that does that, but this effort is something that's as a standard way to do these kind of things. So actually the project started in 2016, initial version with 1.0, which only CDI, JAX-RS, and JSON-P, so most likely you'll recognize these specifications because they're pretty much everywhere. And the idea was to provide application portability across runtimes, either application servers or even cloud providers. So the idea is that you can even pick up your MicroProfile application, deploy it on OpenShift, pick it up and deploy it on Azure, and they will work the exact same way. Now, 3 years later, we are already on version 3.1 since this month, actually. And look how much we accomplished in these 3 last years. So we have a configuration spec, we have a fault tolerance spec that allow us to do circuit breakers and retries and fallbacks. We have JWT propagation to do security with authentication and authorization and JSON web tokens. We have health checks, which are interesting for Kubernetes for readiness and liveness endpoints. We have metrics, so you can extract metrics on your application to see how many times your applications were invoked or timed. We have open tracing, so when you have multiple services calling each other, you can just trace your calls across all the services. You have Open API, which allows you to provide an open API file or Swagger to document your REST endpoints. And you have Rest Client, which is a type-safe way to invoke other REST endpoints. And later on, we also have the JSON-B that's coming from Jakarta E. So there is a lot of stuff over here. I'm going to show you just a couple of samples. But the idea over here is that you can use MicroProfile to help you develop microservices in a standard way. So even we have all of these specs, you also see that a lot of them got other versions. So even, for instance, OpenTrace is already version 1.3. So they're being rapidly evolving across these last few years. So the project's being really, really fast and really, really engaging in updating all the specs to answer the last couple of difficulties and challenges when you're building microservice applications. So who's involved in MicroProfile? This is one of my favorite things about the initiative, which is you have all of these big companies involved in that. So you have companies like Oracle, Microsoft, Red Hat, IBM, really big companies working on that. And then you have a couple of other smaller companies like Tribe, Payara, and Hammock. And you also have communities like the LGC, London Java community, and the So Java Brazil, which is one of the biggest Java communities in the world, in Brazil. And also individual contributors overall. So one of the things I like the project is you have all these minds from all these companies working together to come up with specs and ways to develop these services. There's already a lot of MicroProfile implementations out there. So you have one for Payara, we have Thorntail that's coming from Red Hat, Apache Tommy coming from Tommy Tribe, Amok coming from Oracle, Liberty coming from WebSphere. So you just pick your own, and you can just move your application around, and if you keep with the specs, it should work the same way. Okay, let's now show how we can just take advantage of some things about MicroProfile and interpret that with other languages. So let's just start with configuration. So with microservices, all applications require configurations, right? So either because you need to configure endpoints that's going to call other services, or you want to configure, for instance, the currency of your application, whatever you would like. So when I was looking into that, and I was trying to do things with Node and Ruby, I found out that, for instance, there is something called Node convict and ruby.env. So that seems that when I'm not really a Node or a Ruby expert. When I was looking for ways to do configuration, those were the things that I found. In Java, of course, MicroProfile config. So now you see, now you have free libraries that you have to use if you want to configuration on these languages, right? So let's try to change that a little bit. Now, to see how configuration works in MicroProfile config, this works very simple. So you have an API called config provider. You call get config. You get a config object, and then you can do config get value with a key, and that key is going to retrieve a configuration for you. So the configuration can even be, it's loaded for something called config sources, and config sources can be, for instance, a properties file, environment variables, or system properties, or you can write your own. So I'm not going to go into too much detail over there, but for you to have an idea. Okay, so now let's do a demo over here. So now, of course, I have to build this number API service again, right? Let's put that one over there. And I'm using MicroProfile config on my number API in Java. So now, one of the things that I can do is, so I can say export. No, not that one. Okay, so I can do export. And for instance, I'll say 5001. And this basically is overriding the environment variable for number API port. So if you see the code on, where is it? Number application. Oh, that's not the project. Where is it? Okay. Okay, so if you see the code, you have like config provider, config, optional value, number API port. So this is going to load the configuration for the environment variable. And now you see if I do a Java jar again, now it's running on 5001. And the cool thing about this is this also works in native mode. So if I run number API with native mode, it also is loading the variable from the environment, or loading the config from the environment variable. So now I can even configure my application using MicroProfile config in native mode. But now, of course, there's a new person that comes in on the team, doesn't like Java, and decides to write this in JavaScript. Okay, so let's see the JavaScript version. So let's see, and you have here number API. So don't mind that portion over there. So now it's using Node with something called Express, which is an HTTP server. So again, they'll do expose that endpoint, number API, number generate, and then gonna generate the number, right? But now I want to configure my application to set up the port. So now you might see that I'm using something over here like java.type org eclipse microprofile config provider. So that's a fully qualified name of the config. And now I can just call it directly as I will do any Java code. So now you have a config variable. I can do config get optional value, a number API port. I pass in the Java type, which is a Java long integer, or I can call it or else for another port. So I wonder if this works. Okay, so I have that one around, native image, library, node. So now I'm calling the node coming from GraalVM. I'm passing in the JVM version, and then I'm passing in a class path for MicroProfile jar, which has the config provider over there. Then I'm calling number API JavaScript. So if I run that one, now it does take a little longer to start than any other JavaScript application because it has started the VM as well. But now you see it's running on 5001. So what I did over here is I was able to pick up a jar from Java, put it up on JavaScript, load something over there, and then use it on my JavaScript code. How cool is that? That's awesome? Well, I'm going to show you a couple of more awesome things. So, of course, if I'll just do export and remove that one, and if I call the same thing again, now it's going to fall back to the one that was on our else, which is 3001. It's over here, right? And I also have a Ruby version for this, which works very similar. So again, you set Java type, pass in the MicroProfile config, get config, you pass in the get optional value, and you can read the value, and you can set the port to something called Sinatra, which is a library that exposes an HTTP server on Ruby. So now you can do the same thing for Ruby. So I should have it over there. So you see Ruby, a VM version, pass in the MicroProfile.jar, and now I can, instead of setting the port by environment variable, I can set the port as a system property. This takes a little bit longer to start as well, as start VM and the Ruby version. But it should start. There you go. So now it's running on port 5001. And of course, if I come over here and curl that, you get the number. So now you're seeing like I have 3 different services that are doing the exact same thing, but using the same library, which is written in Java, to do configuration. Okay, but let's do something more interesting. So that seems to be very easy to do. Okay, fault tolerance. So one of the things that we have on MicroProfile is fault tolerance. So fault tolerance allows you to guide the execution of some piece of logic. So you can implement something like circuit breaker, you can create timeouts, you can create fallbacks, bulkheads, whatever you like. So again, if you look into Node or Ruby, you have things like opposing and circuit box to achieve the same behavior. But you have the same issue, which is, okay, now I have to implement these free libraries, or I can use these free libraries and have the same behavior across all the services that I'm using. So this is a sample. So you just annotate whatever method you like with a circuit breaker or a fallback, and it will apply that logic to that particular method. Nothing out of the ordinary over here. And this is the implementation of a fallback. So if you want to fall back to a piece of code, then you can do it this way. And I'm actually going to mix both of the things with REST client and fault tolerance. So when you're doing microservices, you end up having to invoke several services together, right? And you need a client to do it. You can invoke that manually, or you can just use whatever client you want. So MicroProfile has a client inspired by Feign, if you heard about that before. And there is some equivalence on Node and Ruby. Now, for REST client, what you will do is you say number resource client over there, and then you can say register REST client. You could just create an interface, and on runtime, what the MicroProfile REST client is going to do for you is going to generate the code that's going to actually do the call to that particular REST endpoint. What it actually has is by default or by convention, there is a configuration that you can set to tell what's the host where this MicroProfile or this service that you need to call. So I'll show that in a sec. Okay, so I actually implemented these over here. So let's just say, hey, I want to create a client for people to consume my API. So that I have a number API client over here. And what you see is a number API class, which is an application scope. So this is using CDI. And I inject my REST client to call my number service, and then I just call number service get number, so nothing out of the ordinary over here. The client itself is just the interface that I just showed you. So this is going to be, the implementation is going to be generated on runtime, so let's not worry about that right now. And this is the fallback, so if I'm not able to call the service by whatever means, then I can still fall back to that implementation and I can still retrieve my number. Okay, so, but how am I going to able to integrate with this? Because this is now using annotations and using CDI, so it might be a little bit tricky. Well, there are a couple of tricks that you can use. So depending on the implementation that you're using. So now I have this project over here called Number API Invoker. And if I show you the Python code, so what I'm actually doing is I'm starting a CDI context directly from Python. Then I have the CDI object available to me on Python, which allows me to retrieve any bean that I like from that CDI context, and then I can call methods on that, which are going to be intercepted by the annotations because it's running on Java still, so you don't have to worry about all of that. So the behavior that you have is going to be the same. How cool is that? So let me show you how that works. So I have my invoker over here. So let's run with the, I'll do it with the Python version. So Python actually is called GraalPython for now. It's not calling Python anymore, at least for Graal, but they're going to rename it soon. So now again we have VM, the JVM mode. I pass in the class path. The class path has my number API client jar and has my libraries with MicroProfile in it. Then I'm setting up here a system property that tells what's the URL for my REST client service that has to call at least the base URL for the host. The rest is going to be inferred by the annotations on the path. Then I call number API invoker.python. So was that one I show? Yeah, I showed that one over there. So I have my service here running on Ruby, and now I'm running the Python code. So it's going to take a little bit longer to start this again because I start the VM mode, I have to start the Python code, and also I have to start a Python thing. But now you see it failed. It has a fallback. Basically, it deployed the fallback and give me a number back. But why did it fail? Well, if you look here, I'm actually calling 3001, which is not running something over there. So I was running that on 5001. Okay, so let's run that on 5001. And we should get a number back. There you go. So there you have it. So now what you have is a Java client library that I pick up and I plug it into my Python code, and I'm just calling Java stuff directly, which is basically have the REST client implemented over there and calling it from there. So now I can just come over here on my client, and remember when it just failed because the thing was not up? Well, let's just say, okay, let me add a couple of retries over here. If if I'm able to basically put the service up. So I'm going to add that retry. So I'm going to rebuild service. Not that one. So I'm going to rebuild that client API. That's done. So let me kill that one. And now let me run that Graal Python again. So now it failed, but now it still didn't get out of the application, but now it's retrying by the annotation that I put over there. So now you probably see. So now you see another exception because I put like a max retry 10, delay of 5 seconds. So if I have a couple of things, you're going to see another exception over here. There you go. But let me start the Ruby application again, and hopefully it will be able to connect to the service and give us the number back. So Ruby still not up. Almost done. There. Okay, so actually gave all the enters. So now you have the number. So think about this a second. So now I have my client API completely written in Java. I don't have to worry about writing that into any other language. I can just pick it up, give it to another customer, and he can pretty much reuse that if he's using GraalVM in every other language like Python, Ruby, JavaScript, whatever. And you can even annotate it with all the fault tolerance stuff, so it makes a more resilient API. So the interesting thing over here is that we started a CDI container and able to retrieve beans directly from Java and use them on our code. Okay, so that's the demos for REST Client, fault tolerance, Ruby, and Python. Now, the other thing that I want to show you is to do the opposite thing. Now, have some polyglot MicroProfile in there. Well, let's just say that you want to run JavaScript on Java itself, or R. So, for instance, what you can use is you can write your own scripts, and then you can use them to expose them using MicroProfile via REST endpoints. And the idea is that you have a convenient environment and a consistent environment across all your services running on the same VM. Okay, what do you get from that? You have like a huge ecosystem that you can explore. You can pick up a lot of libraries out there that might tailor your needs. And one of the reasons why we've done that on our company was because we do a lot of data science stuff, and if you're doing any kind of data science, a lot of our people like to write things in Python or R, and then you have to integrate with those, and those were not that easy to integrate. So our idea was, okay, let's try to use GraalVM, create a wrapper library across all of these services or all of these scripts, and then just call it directly into Java so we don't have to expose REST endpoints and we have to deal with that complexity. Okay, so for instance, we're using R to do math statistics and forecasts, and Python, we're using that for doing natural language processing. So we found out when we're doing these kinds of things in Java, there are not that many libraries around. There are other languages more suited to do those things, and maybe you can find other use cases for these languages or a few others. Okay, so let's show a MicroProfile app with some R functions. Before going over there, let me return something before. So remember that when I run the number API as a native, so it runs super fast, nothing out of the ordinary, but I have a 71 meg, which seems to be very big for such a small application. Well, let's see, I have let's have a look into the code. Okay, so if we go to my number API, one of the things I haven't shown you is, so if you see the way that to generate the number, you have here calling a method called generate. But now generate, what it does is it uses the polyglot GraalVM API that creates a JavaScript context, and now I'm actually inlining JavaScript directly into my code, and basically what I'm doing is calling the JavaScript functions to generate that number. How cool is that? Right? Amazing. And that's why the native image is actually so big, because it actually ships with JavaScript interpreter inside. So now you're actually running a native image, which has Java and JavaScript inside of it, right? Okay, so that was mind-blowing, right? But let me show you a more interesting example. So now, what I have over here is I call a calculator API. So the calculator API, what it does is it's just a few simple REST endpoints, so nothing out of the ordinary. So it's using JAX REST. If you're using Spring or Spring Boot, it will be the exact same thing. The annotations will be a little bit different, doesn't really matter. And what I have is a couple of posts which perform an operation for a calculator, in this case add, subtract, divide, whatever, doesn't really matter. And what I actually have done is I created R scripts that do that function. So I mean, these are very simple, of course, because it's a calculator and those operations are simple, but believe me, I'm going to show you a couple of samples later where you can basically write very complex scripts in R and then they'll be able to execute on GraalVM. So now you have these functions over here that are implemented. And now I have these utility that I wrote that what it does is using the polyglot API from GraalVM again and actually loading the script from the context load, doesn't really matter, but creates an R context. It basically here on this eval, it's going to compile that R source and then expose a method called execute. So that execute is going to call this function. So basically when you do the context eval, you get the value. This is from GraalVM polyglot. And there is a couple of methods over here, but the things that basically when you want to call a script, the only method that you have is execute, and this has a varargs object. So you can pass whatever arguments you want, and of course they have to match the arguments that you're going to get on the target language or the target function that you're calling. And now this calculator R, then of course in the end you can just cast it as whatever object you like. So in this case it's a number, so the object types also have to match. So I'm going to run this now, and this is actually, I implement that in Quarkus. So maybe you heard about Quarkus before. I'm not going to go too deep into Quarkus, but just for you to have an idea. But now running this into Quarkus, and what I have is my REST endpoint is calling over here. So let me do a curl, and I call calculator multiply. So now this takes a little bit longer because it also has to start the parse the script. Even though the scripts are small, creating the R context is somehow slow. But it's only on the first execution. I can probably optimize that on my initialization block. But yeah, I mean, I got a 10, so that seems to work. So if I call that now, it's fast. And of course, if I change stuff, we have a 2. And if I put like floating numbers, that also works. So that seems to be fine. Let me call another one, so that's okay. Now what you have is an application that's written in Java that's just calling R scripts under the covers, and you don't even see it. How cool is that? Yeah. So let me show you a couple of more. Complicated samples. I'm not going to run them because they take some while to run. But if you remember when I told you that I was working on the contact center space, so there are a couple of things that you can implement, like Erlang A, which are like functions that allow you to predict the load of a contact center. So if you heard about that before, and now of course our data scientists implemented that here on R. So there's a lot of things that are going on over here that I don't even know of. And they have a couple of other things, so I don't even know what that does. I don't even care. But what we did over here is, again, we use that same structure that's just loading the scripts over there and then expose that as a jar. So now what I have here is a jar that's calling R scripts, and you can use that jar to any other application as long as you run it on GraalVM, and then you're just calling R code that you don't even see. So now you just put that on an application and call it directly. So there is no more REST endpoints to call. There is no more integration that you have to do call this, to call R between Java or Java between JavaScript, you can just take advantage out of this and remove all the serialization, remove all the latency that you have when you're calling REST endpoint, and just call things directly when you want to integrate like this. Does that make any sense? Okay. So that's our demo. So let's share me some final thoughts with you guys. So some limitations that we have, so there's not only good things, there are a couple of limitations. One of the things I already talked about. So GraalVM at this point only supports Java 8, but Java 11 is on the making. It should be available in the next couple of months. So there is not much tooling around. So you can use the regular tools, but as you've seen, I've been doing a lot of the commands directly, especially when you're dealing with Node or Python. If you want to invoke them, you can have to do it that way. Maybe there are some tools that are going to be created in the future to easing it up to create the class paths and figure all of that out. And there are not much information around, so I have to dig a lot to figure out how to do this, especially because there are a lot of GraalVM versions coming up in the last couple of months, or actually in this year. They've been releasing a lot of versions, so things get outdated pretty quickly. So sometimes it broke the things that we have done, but it was easy to fix. But that's what means living on the edge, right? So some of the challenges is like Python is still on early support stages, so they do support most of the language. Some of the libraries are still not there yet, but they're working on that. As I say, broken operating that stuff and living on the edge. So moving on. Production ready. Do I believe that's production ready? I think that's very okay for JVM languages and JavaScript. So far we haven't any issues over there. Other languages may not work fully. We just deployed a couple of production servers running GraalVM with Java and R, and so far it seems to be working quite nicely. For instance, Twitter uses this to run in production, not the polyglot stuff, but using GraalVM in production for performance reasons. So I think it's safe to run GraalVM in production, but you have to try it yourself and see if that works for you. So finally, I believe that GraalVM could be a game changer and change the way that we do microservice development, right? So instead of having multiple services and having all of them communicating by REST, you can still have multiple services, but you can just integrate them at the GraalVM level with all the performance increase by not having latency of HTTP in the middle, plus marshalling or marshalling, and make it easier to integrate with other libraries. You can pick your own language that you like to implement, and then you don't feel afraid of just say, oh, my business or my company already has a bunch of libs over here that are written on this language, so I have to integrate with them, and I have to stick with that language, so because if I move into another language, I will have to implement that myself. Well, no, you can just pick that up and just reuse it like I've shown you. So as you've seen, when you're on Java and you have the static typing, the API is reasonable. When you're using JavaScript, Python, or Ruby, well, the API is not that great, so I will not recommend to abuse it, because it might look weird. But I think it's safe to use in some particular cases. For instance, when you have the client and you want to reuse it, or you have other libraries you want to reuse, you could just have like a particular entry point where you just expose what you want to call, and that's it. So some resources, so GraalVM and on that GitHub account or that GitHub repo, GraalVM MicroProfile on my account, you can find all the samples that I'll show you here today with instructions how to run them. So mostly it's around installing GraalVM and installing some of the language on GraalVM and then run them. That shouldn't be that hard. And yes, I'm guessing that hopefully it will ease some of the pain of developing microservices in the future. At least get some of those ideas out there. I think we have 5 minutes left, so maybe we can take some QA.
Just few questions we can add.
Do you have any questions? Okay, over there.
Yeah, does it support TypeScript, not pure JavaScript?
That's a very good question. I have no idea. I'm pretty sure that maybe you could use TypeScript and then use the JavaScript transpiler to convert that to JavaScript and then run it on GraalVM.
Yeah, that makes sense.
Yeah.
And another question, we can use Java classes, Java code, Java classes in JavaScript, and that's cool. But if we have JavaScript code written in ES6 standard, like classes, and there we can have objects and libraries, can we use those classes in Java?
Yes.
And not only eval some script, but use classes as classes.
Yes, I mean, you will have to bridge them together, but that's possible, yes.
Cool, thank you.
Over here?
Hello. I have a backend Java application works on Oracle JDK. And when I had a Node.js application, I think server-side rendering for React.js. So then I have a contract between them is a REST service.
Yes.
So for me, after your presentation, I feel what if I will compile each other with GraalVM and write some boilerplate code, it will works locally. So it will be it's one process.
Yes.
Is it known case? What do you think about case? Is it? Maybe it's well-known case of usage of this one. For me, it's look wonderful. Maybe this.
Yeah, I mean that's one of the things I start to explore, how to integrate different languages with each other to basically, again, as I mentioned before, when you have to integrate services that are written in different languages, you end up having a lot of effort by exposing the REST endpoints, by using OpenAPI, by doing the calls, and that's not business code, right?
Yes, it's not
So
business.
you're just wasting your time writing integration code while you just might be doing business. If you do it this way, then you just remove all that effort, plus you get the advantage on the performance-wise because you don't have the latency of HTTP, you don't have marshalling or marshalling, so it should work quite nicely. Now, a warning on that is, for instance, while you're able to run JavaScript and JavaScript libraries on GraalVM, you're not able to run Node itself on GraalVM because Node has the single event thread loop, right? And that's not supported on GraalVM. But if you're not worrying about that, and if you want just to use the JavaScript code that you have over there, plus libraries, plus wherever, then it should work just fine.
Thank you.
The last question.
Over there?
Hello. You mentioned the example where some person come up and he don't like Java and want to write in Node.js, but just I imagine that we have such person, for example, he
Yes.
came out, and I would show him, see, you could use call MicroProfile from your code. I think he would say that it doesn't look good to the wrapper around this MicroProfile call, create an NPM package to do, and eventually he would implement his Node.js some library, could say, hey, now I could run the same stuff without this JVM, and he'll be happy that he's doing it completely with only Node.js. Just, I see this, what is the use case for this? I see if you have a legacy, some application, and you have to integrate with that, and you like Java, when I see, yes, you could call, you won't have to rewrite all this Node.js and reuse, but just I believe people from this Node.js world, they could be against all of this.
I mean, that's fine. I mean, in here it's kind of like to be flexible, right? So I'm not telling you, hey, just do everything in Java if you come in Node and whatever. What I'm saying is, hey, you want to write something in Node, but you have to integrate with the Java backend? Well, then you can use it, you can do it this way, right? Or if you have a Java, as I show you, you have a REST endpoint that you need to call, and you already have a Java library out there. They don't have to rewrite the client code in Node. They'll just reuse the client code that's written in Java, and then they'll write the rest in Node.js. That's fine.
Okay, thank you.
Yes, and I think we are pretty much out of time. So I just want to thank all of you that stick to the end of the session. It was really a pleasure to be here in JavaConf and in Russia. So I hope that I return next year. So thank you so much for joining.